Construction sites are, well, they're some of the most dynamic and chaotic workplaces on the planet. Every single day, workers are navigating this constantly changing world of heavy machinery, high structures, and just a ton of hazards. But what if we could give safety inspectors a kind of superpower? What if AI could help spot a tragedy before it even has a chance to happen? Let's dive into how artificial intelligence is being trained to do exactly that.
Okay, let this number sink in for a second. 20.8%. That's more than 1 in 5 of all workplace deaths in the United States, and they all happen in the construction industry. It's just a staggering statistic that screams for better, faster, and way more proactive safety measures. So, to figure out how to make these sites safer, first, we've got to pinpoint the biggest dangers. And in the world of construction safety, it turns out the vast majority of these terrible incidents fall into 4 pretty grim categories. They're known as the Fatal 4.
Now, the Fatal 4 are the main targets for organizations like OSHA, and for good reason. They account for the lion's share of all fatal incidents. I mean, these are the most common, most devastating risks that a construction worker has to face day in and day out.
And just take a look at this breakdown. Falls, they're the biggest slice of the pie by a long shot, responsible for most Fatal 4 deaths. After that, you've got incidents where someone is struck by an object, then electrocutions, and finally, getting caught in or between equipment. These 4 things, this is the absolute core of the problem.
So you have to ask, why do these things keep happening? Well, the tough reality is that traditional safety inspections, as important as they are, they just can't keep up. A human inspector can't be everywhere at once, right? And research shows that because of just how chaotic a job site is, these manual inspections can miss more than half of the potential dangers, often the very dangers that lead to one of the Fatal 4.
And this is exactly where AI enters the picture. The whole idea is to create a digital safety inspector, one that can learn from thousands of past incidents and can see a job site with superhuman attention to detail 24/7.
So, the first step is teaching the AI to understand what's happened in the past. This right here is a direct quote from an OSHA accident report. It's dense, it's unstructured text. For a person trying to analyze thousands of these reports, well, that's an incredibly slow, painstaking process. But for an AI,
it's a completely different ballgame. A large language model can chew through that text in seconds. And as you can see here, it just pulls out all the critical info, the date, the job, what caused it, and organizes it into this clean, structured data. This lets us analyze these incidents at a massive, massive scale. But learning from old reports is really only half the picture. The real game changer is teaching an AI to actually see and understand risk in real time, on a live site. So how in the world does that work? Well, the researchers didn't just show an AI a picture and ask, hey, is this safe? That's way too broad. Instead, they used this really clever technique called chain of thought prompting. Think of it like giving the AI a detective's checklist. It forces it to think things through, step by step, just like a human expert would. And here's that exact process. First, the AI just describes what it sees. Then, based on that, it predicts what could possibly go wrong. After that, it filters all those possibilities down to the most severe risks, and finally, it points to exactly where the danger is in the image. So it all starts with just simple, objective observation. The AI is prompted to just give a detailed technical description of the image, identifying workers, the machinery, the materials, and how they're all arranged. It's basically building a factual foundation before it makes any judgments. All right, so now, building on that detailed description, the AI goes from just observing to actually inferring. It starts to predict potential accidents based on how people and equipment are interacting. So it might see a worker near an open trench and think, hey, risk of collapse, or spot some tools left up on scaffolding and flag a falling object hazard. And this part is absolutely crucial. The AI doesn't just list every single tiny problem it can find. It filters and it prioritizes. It's been trained to zero in on the most critical, high-consequence hazards. Yep, the kinds of dangers that lead to the Fatal 4, making sure the most serious risks get flagged first. So we've got this incredibly powerful technology. But you might be thinking it has to require some massive, super expensive AI model from a tech giant to work, right? Well, this is where the research gets really surprising. To answer that very question, researchers set up this fascinating showdown. In one corner, you've got the giants. These are the large proprietary models. And in the other corner, you've got the underdogs, a new generation of smaller, open-source models that you could run on a local computer for a fraction of the cost.
And the results? They were just fascinating. The smaller open-source models didn't just keep up. They blew the larger baseline models out of the water. This wasn't about size or cost. Turns out the smaller models were simply better at this specific, focused job.
So how did that happen? I mean, how did these smaller, leaner models manage to outperform the behemoths? Well, the secret wasn't more computing power. It was more clarity. It was about the questions they were asked.
The researchers discovered something really profound here. While the bigger models can handle these complex, multi-part questions, the smaller models actually thrive on simplicity. They're less likely to overthink or get confused by a problem, and they do their best work when you just give them one clear job to do.
So, instead of a long, complicated prompt asking the AI to check for, say, 10 different safety rules all at once, the researchers gave it a series of simple, focused tasks. For instance, one prompt would only ask, "Is anyone not wearing basic PPE?" The next one might only check for misplaced tools. And it was this one job at a time approach where the smaller models just shined.
And this really leads us to the core insight of this entire study. Moving AI forward isn't just about building bigger and bigger models. It's about learning how to communicate with them effectively. It's about mastering the art of asking the right question. And that leaves us with a pretty fascinating thought to chew on. This less is more approach made AI dramatically better at potentially saving lives on a construction site. So what other fields, from medicine to finance to scientific discovery, could be totally transformed, not by a more powerful AI, but simply by a more perfect question?